The BitAxe benchmark is a staple amongst decentralized miners throughout the community. It allows you to take your BitAxes or your NerdAxes and even your NerdQAxes with some of the revisions I made out of my GitHub and kind of fine tune the performance of that miner. Rather than chasing just raw hash rate, you're trying to find this balance between hash rate, efficiency, as well as a new feature which I have added called error checking, especially on the BitAxes, because the NerdAxes or the NerdQAxes do not do that. However, now you can on the NerdQAxe. Both of them are error aware during the tuning process. I've just updated it on the GitHub. So whether it's the NerdQAxe, the NerdAxe, or the BitAxe, all of them do error checking while also taking into account all the other parameters to fine tune your hash rate and your error rate and your efficiency. So check it out. But quick interruption because I did patch that after recording the original video. So this video is primarily talking about a new feature that I've uploaded to my GitHub, which will be linked down in the description. Also shouting out the users that came before us that developed the BitAxe benchmark to begin with, as well as going over some of the features of this new error checking capability for our BitAxe benchmark. Once again, if you have a NerdQAxe or a NerdAxe, I urge you to check out my previous videos because you need different tuning parameters because each device draws a certain amount of voltage, certain amount of amps, certain amount of clocks, frequency, all of those vary, but you can adjust it if you learn Python and how to adjust these parameters. And I go over that in a previous video. In this video, let's first shout out the people who came before us. So White Cookie had the BitAxe hash rate benchmark, then Mr. V777, the most recent one, did a revision of it, and that's come out. And I have been tweaking and tuning it. You could see, for example, Mr. V777 is about 21 commits of White Cookies, and then my version is about 16 commits ahead of Mr. V777. So if you go to the link in the description, it's going to take everything that we got from both of those creators that came before us, but some fine-tuning adjustments and parameters to look out for. I already have deployed these on a couple of BitAxes. Again, not chasing hash rate. These two, primarily, they're running low. They're only doing about a 1 terahash overall, but they're running low because I'm hitting thermal limits. I need to repaste them and adjust them, which I would do later on, and then do some refining and tuning later. But they are dual pool mining. If you're new to this channel, dual pool mining has been available for the NerdQAxe, but it wasn't available for BitAxes, or at least it wasn't open source available for BitAxes at the time I created it. So it's available on my GitHub as well, along with the BitAxe benchmark. Matter of fact, if you just go to my main GitHub, you're going to see a lot of repos in there, github.com/serpentxsf, and you're going to see a lot of repositories in there from the ETH Enlarge pill, from Ogata Girl and team, from the dual pool mining feature that I was just talking about, to many others, even dual pool proxy mode, which I covered on in a previous video. However, focusing on just this one, the BitAxe hash rate benchmark has been refined for error aware. What I mean by that is if you look at the top left of your miner, there's a error percentage rate. And if that grows too high, you're sitting at 12, 20%, even though you have an awesome hash rate, it's going to do more harm than good. And you really want to fine tune your hardware to be the best as far as efficiency, hash rate, error correctness, thermal limits, the whole 9 yards. So I need to fine tune these miners, which I've been doing, but I'm hitting thermal limits. So now it's time to repaste them. But what does this thing do? Well, first off, the upstream benchmark sweeps core voltage and frequency and selects the setting with the highest hash rate, reporting joules per terahash separately. But it does not look at the ASIC hardware error rate. On the BM1370 boards, or the chip BM1370, these boards, an aggressive undervolt can look good in hash rate and joules per terahash, while the ASIC reports a double-digit hardware error rate, and the upstream tool will select that point. It will still go by hash rate. The goal here is to pick the setting that is both efficient and has a lower error rate, and to add a fast mode for stabilizing a single unstable ASIC, right? Most of these BitAxes have one chip on it. The error measurement, by the way, for the BM1370 firmware has two different kinds of signals. Error count, which is a cumulative raw counter, and an error percentage, which is a noisy rolling rate. It swings from sample to sample, and it's not cumulative ratio. So deriving total work as error count slash or divided by, I think that's divided by error percentage. I could be wrong about that. And then taking the delta is invalid. The derived denominator can move backwards. So the per combo error metric is a mean of error percentage over the post warm-up samples of the window. What I mean by post warm-up here is your miner can sometimes take a minute to get up to full tilt, especially with the NerdQAxe and NerdQAxe, some of the bigger miners. So we allow it to warm up, and then it starts to check everything. It produces this figure, this number, and the AxeOS reports, which we get in the beautiful GUI that the AxeOS team has come up with. Yes, I altered it, and I put my little branding on it for dual pool mining. If you don't like that, I'm sorry. I could take it off. Let me know in the comments. But with enough samples, it would use a light trim mean, dropping one extreme at each end. So a single noisy sample, which can happen, right? You have noisy samples to one extreme or the other. That can flip the result. Instead, it's doing a mean over a spread of time, looking at the data, and the raw error count delta over the fixed length window is recorded separately as a comparable measure of error volume. If the device exposes no error data, the error rate is reported as unknown and never disqualifies a combination. That's good because, again, you want to look at all the data. In combination or a combination pass passes the gate when its error rate is unknown or below the max error. Default right now is 3.5%, right? You really want to be 0.5, 1% or lower. I know some people that are running 0.25, 0.5, but a passer must also hold hash rate intolerance and leave thermal headroom. So it's got to have enough thermal headroom. And why would you have a high error rate to begin with, even if you're not dual pool mining? Well, if you have your clock set high and your voltage too low, you're going to cause high error rates. And the vice versa. If you got your clock set low and your voltage too high, you can have high error rates. So again, you're fine-tuning your miner to get you the best efficiency per hash, as well as taking into account the thermal headroom, the voltage headroom, or the voltage, right? Your VRM temperature, your ASIC chip temperature and voltage, as well as your error rate. There's 4 modes. Grid, which is the default, which does a full sweep and is now error aware. Wasn't before. The BitAxe Benchmark was not doing that before, which is why I updated it or made some refinements, which brings us to our next title of our second mode, refine, stabilize a single ASIC. It's just focusing on stabilizing voltage, frequency, sweeping the voltage up and down, making sure the error rate's within tolerance, at least below 3.5%, making sure it's got good thermal headroom, so on and so forth. And then efficiency for healthy miners to hold a frequency and sweep voltage down and up from the current setting to the lowest setting to make sure it still clears the ceiling, cutting power and heat with no loss of hash rate, right? Trying to maintain your hash rate while cutting the power and cutting the thermals. And then the last one is check or dash check, which is just read only. It just measures the current setting once and reports no changes, no reboot, no nothing. And sometimes when you apply clocks, you have to reboot the device. So this new BitAxe benchmark that I've kind of optimized, I've taken the original design. Again, huge shout out to Mr. V777, which, by the way, I sent them pull requests, but I don't think they're monitoring this repo anymore. But other people have sent pull requests as well, and they haven't been incorporated. So I incorporated some of the things they did, as well as some of the optimizations and tuning that I have added to Mr. V777, which again was a fork of White Cookie. So a huge shout out to those gentlemen that came before us. And this is where I'm asking you, the community, to help out. Whether you're using dual pool mining or not, doesn't matter. Whether you're using the proxy or not, doesn't matter. If you can check out the link down in the description for the BitAxe benchmark on my GitHub, I want you to see if you first off see if your BitAxe is what the error rates are. If you haven't been paying attention to that and you're sitting around 20%, 12%, 10%, you might want to apply this or do some adjustment manually to get that error rate down. Yeah, again, yes, high hash rate, good. I know number go up, everybody's happy, but it's not just about hash rate. It's about efficiency. It's about your thermal headroom. It's about your voltages or your power draw, and then as well as taking into account your error rate. So if you have a high error rate, I urge you to check this out. If you have a low error rate, go and test this out on a few of your BitAxes and come back and let me know, whether it's in comments in this video, hitting me up on X, hitting me up in the Discord, whatever it might be, and let me know what your thoughts are. Again, just tinkering. The whole reason all of this came up is because a few of you hit me up, especially Tech Man, shout out to you, asking me, hey, I want to be able to dual pool mine because it's available for NerdQAxe. I want to be able to dual pool mine on my BitAxe, but it's not available, or at least I can't find it. We found out that there's a couple sources out there. Some of our colleagues in the community, right? Shout out Solo Satoshi and many others, already have devs that are working on it. Can't remember everybody's names, but that might already be out by the time you watch this video. So check out for that. But most of them were behind gated walls, meaning you had to pay in order to get their firmware, and the firmware was closed source, taking an open source, making it closed source, and then making you pay for it. So the decentralized mining community doesn't really like that too much. And don't forget, you can use these BitAxe benchmarks, BitAxe benchmarks on some of your closed source miners, like your Hammer miners, right? That mine Bitcoin, right? So this is primarily for those type of miners, you know, those ESP32 BitAxe miners, NerdQAxe miners, so on and so forth. But just remember, if you're going to apply NerdQAxe, or you're going to run a BitAxe benchmark on your NerdQAxe or NerdQAxe, you have to adjust a lot of parameters, which I've done in a previous video, and I urge you to go check that out. I'll try to link that down in the description as well. But that's going to do it for today's video. Please hit me up. Please test it out. Please let me know if you have any comments, questions, concerns. Send logs to me. Send data to me, so I can tweak and fine tune and push out more updates to the repo. And do me a favor on the way out. Hit that like button. Make sure to get subscribed. Hit the notification bell to stay up to date. So let's check out additional links in the description. They'll support the channel and what we do here. And you all have yourself a wonderful day. Take care. I'll catch you in the next one.